this chapter, we will be studying the transformations of functions. In this lesson, we will be looking at radical functions.
Okay, so to introduce this idea of the radical function here, we're just going to kind of follow along the notes here. Radical function is one in which the variable occurs in the radicand. Okay, we always name functions in terms of where the variable or the independent variable sits. So, okay, radical function, independent variable is in the radicand or under the root sign. So then our function here, y equals f of x, okay, is going to become kind of the square root of f of x. In essence, what we're kind of doing here is performing a bit of a transformation here. We're taking a function and taking the root of it, okay, finding the root of it. Now, a radical function is going to have a restricted domain, okay, if the root index is even. In other words, if you're taking a square root or a fourth root or sixth root and so on, then you're going to have a restricted domain here. What would happen here is this f of x, okay, and this is stated right here, the f of x has to be positive. Okay, in other words, what you plug in or what you put under that radical symbol has to be positive. Okay, the range is going to be all of the square roots of those numbers, or all of the nth roots, whatever that happens to be of that particular function. Now we're going to take a quick look at just a basic square root function here in just a second. I'm going to want to point out some of the properties here that relate back to what we were just talking about. So here's the most basic radical function is y equals the square root of x. And here's our graph here, okay? Notice that it doesn't extend, okay, into the quadrants 2 or 3 here. Okay, it doesn't drop below into quadrant 4. This is only a quadrant 1 function here. It's got an x-intercept of 0, y-intercept of 0, hits the origin, that's fine. Notice that its domain is greater than or equal to 0. Okay, I can take the square root of 0, please be aware of that. You can do that. But then I want all of the input values here to be positive. But additionally, and this is the part that often gets overlooked here, that the product, the result of a radical function is always going to be positive or 0, okay, because again the square root of 0 will be 0. But the radical function will not produce negative numbers. And that's an important point that we're going to explore later on in some of these examples here. Now, like it says down here, just like other functions, okay, you can transform a radical function. Okay, it's just bear in mind that this thing up here is our base function, but everything else that you would kind of assume that we have looked at in the previous few lessons here about transformations, they all apply here. So here's our kind of general set of transformations that we're applying here. A is responsible for the vertical stretch or reflection. B is a horizontal stretch or a reflection. And then H is responsible for horizontal translations, and K is responsible for vertical translations. So there's nothing new here. We can do all the exact same transformations to this function as we've done to every other function. And the rules still apply here. So for example, that B, that is a horizontal stretch by a factor of 1 over B. Okay, you'd still reciprocate it and so on. So nothing new in that regard.
Given the function f of x is equal to the square root of 3x plus 1, write the equation with the following transformations.
All right, now this is just to illustrate once again that this function behaves like any other function here. So this is a vertical reflection, it's outside the function, but remember that in this case the entire function looks like this, consists of 2 terms. And so when you put that negative through, it has to distribute to both terms. So this becomes negative root 3x minus 1. Okay? It doesn't just sit in front of the root 3x because it's in front of the function, and the function is this whole thing here. There's 2 parts to it. Over here, this negative is inside the function. And so when we write this out, okay, this is on the x itself here. So I'm going to replace x with negative x here. And so I'll just multiply that out here. There's really not much to be done. It's just going to be negative 3x plus 1. Now, at first you might think, well, there's a problem there because there's a negative underneath the radical. Yeah, that's true. That's true. But this is causing a horizontal reflection. So as long as the values of x are also negative, then what will end up being in here will be a positive, and that'll be okay. I can take the square root of that. So that's fine. So anyway, that's what that particular function will look like.
Describe the transformations of y equals the square root of x in order to obtain the graph of the following.
All right, so to get the transformations here, we basically got to list them off left to right. But we have to make sure that we have separated the translations and the stretches here. Now in this first one, that's not a problem. So the first thing I bump into here is a vertical reflection. That 3 there is a vertical stretch by a factor of 3. Now once I move inside the function, it's a little different. That 4 there is a horizontal stretch by a factor of 1/4, because to get x by itself I would have to divide by 4. That x minus 2 is telling me that there's been a horizontal translation of 2 to the right, because to get x by itself I would have to then add 2. And outside the function I've got this plus 4, which is a vertical translation 4 up. Now y has already been isolated. What did I do? I added 4 to make it look like that. Over here, don't let yourself get sucked into this. Remember, I got to rewrite this function here. I got to separate out what's underneath the radical here. I got to separate out the stretch from the translation, meaning I got to write this as -1/2 x. Now, what is -4 divided by -1/2? It's going to be +8 with a plus 10 there. Okay, so -4 divided by that -1/2, got to take that out, and now I've separated the translation, the stretch from the translation. Now I should be able to see more clearly what's going on. First of all, there's been a horizontal reflection. That's what that negative means. There's been a horizontal stretch by a factor of 2, because to get x by itself I would have to multiply by 2 to get rid of this. There's been a horizontal translation 8 left, because to get x by itself I'd have to subtract 8. And then finally that 10 is outside the function. The y is already isolated, so what did I do? I added 10, so it's going to be vertical translation of 10 up.
Write the equation of the radical function that results by applying the following set of transformations to y equals the square root of x. A horizontal stretch about the y-axis by a factor of 4, and a horizontal translation 5 units to the left.
All right, just like we did with other functions here, the best way to do this is probably to identify the replacements here. So a horizontal stretch about the y-axis by a factor of 4 means I'm going to replace x with 1/4 x. Okay, and then a horizontal translation 5 units to the left means replacing x with x plus 5. So to start off with, we're going to get y equals the square root of 1/4 x. Okay, and this is, remember, this is all under the square root. And then, okay, it's 1/4 x. This 1/4 is being multiplied by x, and when I replace x with x plus 5, this is going to become 1/4 bracket x plus 5. And so that's what that is supposed to look like. Very consistent with what we did in the previous chapters here.
Write the equation of the radical function that results by applying the following set of transformations to y equals the square root of x. A reflection about the x-axis, horizontal translation 1 unit to the right, and a vertical translation 7 units down.
Okay, so once again, we're going to take this in pieces here. Reflection about the x-axis means replacing y with -y. Horizontal translation 1 to the right. Okay, that's going to be x minus 1. And then a vertical translation 7 down is going to be replacing y with y plus 7. So now we start this off bit by bit here. So first of all, it's going to be -y is equal to root x. Then it's going to become -y is equal to the square root of x minus 1. And now notice that the negative is in front of y, so when I replace y with y plus 7, it's going to be negative in brackets y plus 7 equals the square root of x minus 1. Okay, now I'm going to isolate the y. Okay, I'm going to try to get that by itself. So I'm going to bring the negative over first, so y plus 7 is equal to negative root x minus 1, and then I'm going to subtract the 7 so that we get finally y is equal to negative root x minus 1, and then out back here, minus 7.
Write the equation of the radical function that results by applying the following set of transformations to the graph of y equals root x. A vertical stretch by a factor of 3, and a horizontal stretch by a factor of 2.
Right, so the pieces here say a vertical stretch by a factor of 3. So that is going to be replacing y with 1/3 y. Horizontal stretch by a factor of 2 means replacing x with 1/2 x. And so now in my equation, that is going to be 1/3 y equals root x, and then 1/3 y is equal to the square root of 1/2 x. But I want to get y by itself, so I'm going to multiply both sides by 3, so that's going to be y is equal to 3 times the square root of 1/2 x. That's the function I'm looking for.
Write the equation of the radical function that results from applying the following set of transformations to the graph of y equals root x. A reflection in the y-axis, translation up 3 units, and a translation left 2 units.
Okay, so in this case here, reflection in the y-axis, that means changing x to negative x. Translation 3 units up here is going to be replacing y with y minus 3. The translation to the left is going to be replacing x with x plus 2. So initially we get y is equal to the square root of negative x, and then y minus 3 is equal to the square root of negative x. But now the negative is sitting outside the x, and I'm going to replace x with x plus 2. So that means that negative sits in front of the whole thing, x plus 2. Okay, got to put parentheses around that. Now my last step here is really just going to get y by itself. So y is equal to the square root of negative x plus 2 plus 3. That's what I'm looking for.
What vertical stretch is applied to y equals the square root of 2x plus 1 if the transformed graph passes through the point 4, 18?
All right, now the trick to doing this question here is, again, to approach this in functional form here. What vertical stretch is applied to this? Okay, I don't know what vertical stretch is going on here, but I am taking and creating a new function from the old function, the old f of x here, by applying a vertical stretch. Now that's what a vertical stretch looks like. In this particular case, I know what the function is. Okay, that's going to be the root 2x plus 1. So g of x is equal to that. Now, I know that this new function passes through the point 418. I was given that information. So I can replace the dependent variable here with 18 and the independent variable here with 4. And now I just evaluate here. 2 times 4 is 8, plus 1 is 9. Square root of 9 is 3. So when I divide, I get that a is equal to 6, which means a vertical stretch by a factor, whoops, can't see that, by a factor of 6. Yeah, that's the function, that's the stretch factor I'm looking for.
As a result of the transformation of y equals the square root of x into the graph of 2y equals the square root of x plus 1, the point P, 64, 8, is transformed to the image point Q, AB. Find the coordinates of point Q.
Right, so in this case here, this question is nothing different than what we've seen earlier in this chapter here. It's just happening to a radical function. So if we take a quick look at what we're seeing here in the function, I've replaced y with 2y. Now that means a vertical stretch, okay, by a factor of 1/2, because I'd have to divide by 2 to get that over. That x plus 1 means a horizontal translation 1 to the left, because to get x by itself I'd have to subtract 1. So this means my image point x comma y is going to become the point x minus 1, 1 to the left, and then 1/2 y. So now, with that in mind, the point that I'm given here is this point 64, 8. So 64 comma 8 is going to become the point, well, okay, x minus 1, so 63, and then half of 8 is going to be 4. So the new point here, Q, is going to be this point 63 comma 4.
The graph of f of x is equal to root x, where x is greater than or equal to 0, was translated horizontally and vertically only. The domain of the translated graph is the set of x values such that x is greater than or equal to negative 10, and the range is the set of y values such that y is greater than or equal to 2. Describe the horizontal and vertical translations in words and using the notation f of x is equal to the square root of x minus h plus k.
Okay, now this question actually, it looks like a lot going on, but there's actually not that much going on here. And I just want to figure out what the transformations are and then write out the function. What you got to remember here is with this starting function here, this root x, the domain should be, x is greater than or equal to 0. It became x is greater than or equal to negative 10, which means this thing moved. There was a horizontal translation 10 to the left. Okay? The range should be y is greater than or equal to 0. It is, in fact, greater than or equal to 2. Okay, it is greater than or equal to 2. So there's been a vertical translation to up. Okay, so let's put that into my function here. Think about how that works here. F of x is going to equal the square root. Okay, I want this thing to go 10 to the left. That means x plus 10. Because now to get x by itself, I'd have to subtract 10. And if I want 2 up, I have to add 2 outside here. So there's my new function there.
The point 4, 10 is on the graph of the function f of x is equal to k times the square root of 3x minus 1 plus 4. What is the value of k?
Okay, now this question is a little bit of a flashback to what you would have done last year in math, solving these kinds of equations. We know that the point 4 comma 10 is on this function. So that means I can replace the f of x with 10. This is k, square root of 3 times 4 minus 1, and then outside the brackets plus 4. So I'm just going to evaluate for k. So first of all, I'll bring that 4 over, subtract it from both sides, I get 6 is equal to k. Now, 4 minus 1 is 3, times 3 is 9. Square root of 9 is 3, and then divide, and I'll get k is equal to 2. Yeah, not a lot going on in this question. Actually, it's pretty simple, straightforward.
The point 4 comma y is on the graph of f of x is equal to root x. The graph is transformed into y equals g of x by a horizontal stretch by a factor of 2, a reflection about the x-axis, and a translation up 3 units. Determine the coordinates of the corresponding point on the graph of y equals g of x.
Okay, I kind of like this question here. We're told that the point 4 comma y is on the graph of f of x equals root x. Now, they leave this y as if it's some sort of crazy unknown, and if you go through the problem here and you don't figure out what y is soon, you might think that this question can't be answered. But just take a look at this. The point 4 comma y is on the graph of the square root of x. Y is equal to the square root of x. Well, the x in this case is 4. What's the square root of x? Well, the square root of 4 is 2. The point here is 4 comma 2. That point, if it's on this graph, should be 4 comma 2. Take the x, plug it in, root x, root 4 is 2. Okay? A lot of times when we go over a question like this, people just don't see that. As soon as we throw that unknown there, all of a sudden, whoop, not a clue what's going on here, even though we give you the function. Anyway, let's keep going here. This graph is transformed into g of x by a horizontal stretch by a factor of 2. Okay, so a horizontal stretch by a factor of 2. This means g of x is going to be f of, horizontal stretch by a factor of 2 means I'm going to put 1/2 x in there. A reflection about the x-axis, that means we're going to make that function there, or actually, well, no, I'll leave it like that. We're going to leave the negative in front of the g of x there, f of 1/2 x. Translation 3 up. Okay, so it's going to be minus 3, but in brackets there because, remember, we're doing that translation. We're doing that translation afterwards. We're replacing that in there. And so this is f of 1/2 x. Now, bring the negative over. Okay, bring the 3 over. This would be add 3. And now let's just plug this into my radical function here. So my new function g of x is going to be the negative square root of 1/2 x, the plus 3 outside there. Okay. Now, I probably didn't have to do that. That's not bad practice. Really what I'm interested in is what the image point is. And this is going to be, okay, it's stretched by a factor of 2, so 2x, reflection in the x-axis, and a translation 3 units up, so then the point 4 comma 2 is going to become the point 8 comma, okay, negative 2 plus 3 is going to be 1. So 4 comma 2 will become the point 8 comma 1. I probably didn't have to do all that, but it was fun anyway.
Write the equation of each of the radical functions in the form y is equal to a times the square root of b times x minus h plus k.
Okay, to get the transformations that have occurred here, you kind of need to understand what they're giving you here. Now, the points here, it would make more sense if we started with the original. The original function, just a basic y equals root x would start here, would go through here. This would be the next point that they would identify. The next point that they would identify would be at 4, 2 right through there, and then it would be 9, 3. So it would look something like that. Okay, so the point is to go from this point to this point here, the next one on this graph, there's a horizontal move of 1 over 1 up. So this is my root x. If you look at the graph that we've got right here, this is 1 over 3 up. Okay, in this case here, this point compared to this point is 1 move over horizontally, but 3 up. So there's been no horizontal change, but there has been a vertical change, and that is a vertical stretch by a factor of 3. Okay, we'll deal with that in a second here. There's been no reflection, nothing else here, so after that it's only translation. Now, a vertical stretch would not change the origin here. So it's been moved 4 to the right, horizontal translation 4 right, and vertical translation 2 up. So now we're going to put this into that equation. So y equals a vertical stretch by a factor of 3 will be 3 root. 4 to the right will be x minus 4, and then 2 up will be plus 2. So that's the equation for this particular radical function.
Write the equation of the following radical function in the form y is equal to a times the square root of b times x minus h plus k.
So once again, with this particular function here, you got to understand what the original looked like. The original started here, 1 over 1 up went to there, 4 over went 2 up, and then like 9 over went 3 up. So the graph looks like this. Here's the original y equals root x. Now, to go from this point to this point was a horizontal move 1 over 1 up. Okay, and you got to be clear on that. Now, when you look at what's going on with the graph here, I think you can tell immediately that there's been a vertical reflection. I think that's pretty clear. Because this thing moves up like this one's dropping down. So it's been vertically reflected. Now, these 2 points are supposed to correspond to these 2 points. So notice again, this one's horizontally 1 over and then 1 up vertically. This one is 1 over horizontally, but 2 up vertically. So there's been a vertical stretch by a factor of 2. And then there's nothing else to speak of, okay? So the rest of this has all got to be translation. These 2 will not affect the origin here, the point that goes to the origin. So now I just have to figure out how that point moved to get to here. And it went 3 left, so a horizontal translation 3 left, and then a vertical translation 4 down. So now I just have to put this into my equation. So y equals, well, okay, vertical reflection is negative. Vertical stretch by a factor of 2 is going to be negative 2 root. 3 to the left is going to be x plus 3, and then 4 down will be outside here minus 4. And that is the function for that particular graph.